Hi everyone, welcome to this webinar hosted by CVStruct and Prota Software. Emmanuel Ochieng. Yeah, so today the webinar will be on step-by-step structural BIM design using Prota. And our presenters will be Volkan, who's a civil engineer with Prota. He has a master's degree in civil engineering and has been working for years and is specialized in Prota Software. And we also have Burke, who's a senior business development specialist with Prota Software. So I hope that we'll have an interactive session. It's a live one, so you can ask questions. Feel free when Volkan is presenting, you can type in the chat. Yeah, I hope we have a good time, and I'll then hand over to Prota Software.
All right then. Thank you, Emmanuel, for the introduction. Okay, and minimize this thing. All right, cool. Well, welcome again, everyone, and thank you, Emmanuel, for the introduction. This is Berk from the business development team at Prota Software. I would like to thank CVStruct Integrated Systems as our partner for organizing this event for us. And we look forward to the great days ahead in Kenya and beyond with our partner. Also, I'm aware that we have a Board of Engineers of Kenya attending. I welcome you all, as well as other attendees, and thank you all for joining today. So our agenda for today covers Prota Software's quick background and what we offer, our core advantages of our software technologies and services. I will then hand over to Volkan for a detailed demonstration and some hands-on experience. Now, you might know ProtaStructure 2022 is a unique platform for building design, and for the sole offering, it's the sole offering that we provide to our customers today. ProtaStructure 2022 is unique, but what makes it unique is that it is a one-stop shop for analysis, modeling, analysis, design, detailing, fabrication, and BIM processes, seamlessly allowing you to integrate the whole process in a single solution. Now, this allows our users to rapidly deliver their projects using a single software. Hence, it is the reason we refer to our software as an all-in-one or a one-stop shop. Now, you're looking at the four modules that is the ProtaStructure suite, and we call it the ProtaStructure Enterprise Suite. It consists of the four modules that starts with ProtaStructure, which is the core system for modeling, analysis, and design of your structures. It is then complemented with Prota Details, which is a CAD system for automated detailing and drawings. It focuses on concrete detailing and includes a unique design library of calculations for designing things like retaining walls and piles. Now, with Prota Steel, it complements your steel design by automating all steelwork connection design, providing comprehensive steel detailing and automating your connection design of your structures. Now, it is important to know that we provide drawings and calculation reports with ProtaStructure, Prota Steel as well. And finally, the Prota BIM allows you to connect with other tools and systems that you may be using, allowing you to collaborate better with team members. Prota BIM allows you to communicate with other BIM platforms and software solutions like Allplan through IFCs or ArchiCAD through SAF. You can also share your analytical data with SAP and ETABS. Now, here's our numbers with Prota Software page, basically, just to give you an overview of our organization. Now, we've been expanding our reach around the world, covering 25 international design codes, and we currently have 9 languages. Some of them include Polish, Spanish, Portuguese, Thai, and English. We've also been busy creating design guides and insights into how the software functions. For example, many of our users benefit from technical guides that cover guidance to punching shear checks, foundation design, seismic design, retrofitting, and many other topics. At this point, we support over 85 countries around the world through our partners, like in Kenya, through CVStruct and our offices directly. And you can see these figures represented through the numbers associated with them on the screen. I think I may have skipped one slide. Let me just go back. All right, now we've got the world map on the screen. I've mentioned that we've been expanding and we're definitely rapidly expanding into different countries, and you can see that our partners are represented by the yellow dots, and the hexagons represent direct presence in those nations. We're determined to continue increasing our partner network along with our user base, and it's only a matter of time, I think, in the next presentation that you will see these dots definitely incrementally increase. So let's begin with our history. Now, I want to briefly summarize some of the key milestones of Prota Software's journey throughout the years. Some of you might actually know us from back in 1992, as Prota launched ProBin Orion, which is the world's first concrete building design and detailing system. In 2005, ProBin Orion had provided the first ever building solution for retrofit and rehabilitation. In 2007, we've invested in BIM technology and launched Prota BIM, which, as mentioned before, provides bi-directional physical model integration. And today, in 2014, we've got the suite that we currently present to you today with ProtaStructure. And in 2018, the Prota team delivered the world's largest passenger terminal building. The structural design of this project was delivered with ProtaStructure Suite. If you'd like to read more on this, you can visit our webpage, which includes various success stories in all its detail. And in 2022, as I've mentioned earlier, we stand having spread the software in 85 countries and continue to cement our place in the global market. Now, as you know, there are several BIM software solutions that offer various services, and you can see the scope of these on the screen as they appear. And as Prota Software, we believe in creating a software solution that our engineers can rely on as an end-to-end solution, basically. And you can see the scope that we cover. Now, our core advantages is that we provide all of this in a single suite, as I mentioned earlier. So we like to think of ourselves as a software for streamlined modeling and analysis. We are a software for designing your steel connections, concrete beams, core walls, foundations, and more. We are a CAD software for dedicated structural drafting and producing all your engineering drawings with component design for other project elements like retaining walls. We're also a fabrication software for producing all your construction and shop details. And lastly, we are a BIM software for communicating all of this to other project members. Now let's have a look at these components very quickly. I won't take too much of your time, but let's have a look at it. So ProtaStructure forms the core of our suites. It is a BIM design solution for concrete and steel buildings. Some of the capabilities offered in general are flexible 2D and 3D modeling, multi-material modeling with physical objects, analysis and detailed design to international seismic and design codes, full design reporting and quantity takeoff, and so on. Now, with ProtaStructure, our aim is that your business will benefit from rapid modeling on an easy-to-use platform while effortlessly creating your intelligent drawings and full design documentation with the availability of a wide range of international design and seismic codes. On to Prota details. It works with ProtaStructure. It is a revolutionary system for automatically creating and organizing all your structural concrete detail drawings rapidly. And you can save hours of drafting time by seamlessly extracting design details from ProtaStructure and automatically arrange them onto your company drawing sheets. We continuously expand our library of component macros and Prota details, which in return save time and cost to our clients' businesses. With Prota Steel, it is our all-in-one steel drawing solution that allows our structural engineers and detailers to perform automated steel connection design and produce high-quality steel drawings in just a few minutes. Now, you can take models designed in ProtaStructure, import them into Prota Steel, and save hours with the automated design of a comprehensive range of bolted and welded steel connections of your choice. And finally, with Prota BIM, it has been designed to allow engineers to easily create, communicate, and coordinate models with other project stakeholders, including architects, fabricators, BIM specialists, and project owners. And using our revolutionary Prota Hub technology, you can easily create models from a range of data formats such as 2D and 3D DXF, IFC, SAF, and Autodesk Revit, which Volkan will delve into soon. Now, we've developed ProtaStructure with BIM in mind, and you can see a flow chart. The entire BIM flow of our software solutions is available on the screen. Remember that all these solutions are offered in a single economical suite called the ProtaStructure Enterprise, as I mentioned earlier. And just to recap on each of the features that are delivered, number one is you can bidirectionally link your models to other BIM platforms and software solutions like Autodesk, Revit, Allplan, and ArchiCAD with latest data formats, including IFC, 2D, 3D, DXF, and SAF. Number two, you can use Prota Details, our structural drawing and detailing software, for automatically creating and organizing all your RC detail drawings only with a single click. And thirdly, you can take models designed in ProtaStructure directly into ProtaSteel and save hours of automated design of a comprehensive range of bolted and welded steel connections of your choice. You can then transfer and compare your analytical model with other general purpose analysis software, such as ETABS, SAP 2000, and Lucis. And lastly, you can create and share highly visual calculation reports featuring Microsoft Office and PDF export capabilities. Now, product excellence is very important for us. It is also a necessity in our sector, and I think it is key to our success and our continued growth as an organization. ProtaStructure is being used by thousands of large enterprises all around the world, and I think it definitely speaks for itself. If you may have heard some of the logos on the screen, worth mentioning are AECOM, Sunway, Arup, WSP, and Jacobs. These organizations have been using our products to deliver their engineering projects in excellence. Now, as I've mentioned earlier, ProtaStructure was used in modeling and designing of the biggest passenger terminal building of the world, located in Istanbul, which covers an area of 1.5 million square meters. And Mr. Daniel Kubin has made a statement attributing the added success to ProtaStructure's ability to perform project variations quickly, economically, and accurately. Now I'll continue with some of the projects that have been completed with ProtaStructure. I think it will give you an idea about our strengths as well as our portfolio. Now, what you can see on the screen is the largest university campus project in Istanbul. That was also delivered with ProtaStructure Suite. There were over 50 buildings within the campus project covering 1 million square meters of construction space. There are also some prestigious projects that have been delivered from our clients across Southeast Asia and Europe, such as the Stage Building and Camel Street in London, as well as the Stoner, IPA Hospital, and Oasis Tower in Kuala Lumpur. Again, our client in TWT Design Consultants have delivered very prestigious structures using ProtaStructure. A few other examples coming from Kuala Lumpur and Jaya in Malaysia. You can see Garden Mall, Resort City project that was delivered in Malaysia using ProtaStructure Suite. Again, a shopping mall in Singapore is among other projects that were delivered. Several hospitals were also designed with ProtaStructure, and one worthy note is that these hospitals were seismically retrofitted buildings. And with ProtaStructure's unique seismic capabilities, you can insert seismic isolators into your buildings as well. These are international airports and terminals in Egypt, Kosovo, Russia, and Turkey, delivered with ProtaStructure. Oh, we already mentioned that, I think. So multi-purpose buildings can also be designed with ProtaStructure Suite, and this project specifically comprises of residential buildings, swimming pools, indoor parking lots, and office spaces. Another unique example is this data center made by ProtaStructure. It stands out with its state-of-the-art technology as well as with the security capability that it offers. Another important note is that the center is made to be earthquake resistant, and it utilizes a total of 87 seismic isolators in its floors. We're looking at the USA Embassy building located in Papua New Guinea, which was also designed with ProtaStructure Suite. As a summary, you can see that our strength lies in buildings and building-like structures. You can pretty much design any type of building with ProtaStructure Suite. But having said that, you can create other variety of structures using ProtaStructure. And some of the examples, as you can see on the screen, are stadiums, auditoriums, playground roof, as specified here, hangar building, modeled and designed for our users around the world, and they continue to impress us with the creativities. So what do we offer to clients that have become customers might be the question that comes to mind. Our licensed users of ProtaStructure do not just benefit from their licensed software technology alone. We gift every new license owner with a year of maintenance to ensure a smooth onboarding process. Now, with this framework in mind, our customers are given access to our comprehensive and dynamic Prota Help Center platform, where they're given the ability to browse through our collection of knowledge-based articles. The customers in this platform can create unlimited support tickets to get help from the Prota support team 24/7. They can view these tickets and follow up on their status. They can also ask questions in the forum with engineers alike that use the software and easily share information. On top of that, customers are able to receive updates and new releases during their maintenance plan. And for more information, you can always reach out to myself directly or to the Global Business Development team separately on this, and we'll be happy to meet you and give you further details. As I mentioned earlier, we've been writing a lot of white papers, which are technical documents highlighting newly added features. So feel free to visit protasoftware.com today and have a read. I'm sure you will be interested to learn about the technical details surrounding these features. And of course, more material is made available to paid users through Prota Help Center. But we've got a lot of free content on whether it be social media or on our website to give you a really good idea about what we're talking about here and our capabilities with our software solutions. We definitely emphasize big importance on transparency and put much effort on being transparent with our users. We do our best to create a healthy two-way communication from our community to ensure that ProtaStructure Suite continues to benefit engineers around the world on a daily basis. As I mentioned, our YouTube page is great for browsing through webinars, and those playlists have been organized really well by my colleagues in the marketing team to make sure that you can navigate easily. You can watch your recent webinars. I'm sure this is going to be uploaded at some point as well. And you can go and watch your tutorials there and really understand what some of the key features of ProtaStructure are that I'm trying to highlight here. Now, let me just show that on the screen first, I guess, before I talk about it. Now, we're available on all of the social media platforms, as I mentioned earlier, whether you're using LinkedIn, YouTube, Facebook, Instagram, or Twitter. If you use any of these, chances are you can easily follow us and keep up to date with any of our doings. And if you're interested in our offerings, you can contact us through our global sales at protasoftware.com email, or you can go to protasoftware.com and there's a contact us link on the right top corner, and you can fill one of those forms and we'll be happy to get back to you as soon as we can. And that's all I had. Thank you for bearing with me for this long. I know you're excited to see the software live. I'll pause here and let Volkan take over for a demonstration. Volkan, feel free to share your screen.
Thank you for the informative presentation, Berk. So today we will talk about how we can create a 3D model that includes some information inside. So, and we will talk the BIM capability of the software. So let's just start. My name is Volkan Ogut. I'm working in Prota Group since 2012. And I'm currently working in our Warsaw office. So let's just start with our agenda today. First, I would like to a bit clarify what is BIM. So then we will talk about ProtaStructures and BIM compatibility. And of course, we will create a model from scratch, and we will share with the other softwares during the webinar. So what is BIM? BIM is actually not a software. Even some of my even colleagues, engineers, are asking, do you have BIM software? Like, BIM is not a software. BIM is a methodology. So you can think about a database that includes 3D model, and we can add some parameters or some informations that will be used throughout the building's life cycle, from initial design to construction, operation, and maintenance. Okay, so but what about ProtaStructure and BIM? Why should we use ProtaStructure for this BIM compatibility? Because ProtaStructure is easy to use. You can quickly create a model, share with other platforms. The second reason is like ProtaStructure is like all-in-one tool. You can model, design, detail, create your fabrication details, and share your model with other BIM platforms. And of course, the third one is collaboration with other softwares. Like ProtaStructure can collaborate like industry leaders such as Revit, and it will allow you to import and export data easily. So here you can see that you can quickly select the model and import to the Revit environment. If you need, you can just map the families with our sections. So ProtaStructure is a robust and flexible software that seamlessly integrates with industry-leading BIM applications, and to streamline building design and detailing workflows, enhance project efficiency, and minimize costs and errors. So let's see our collaboration capability. We can use our Prota BIM add-on to integrate our model with Autodesk Revit software. So the second one, IFC import and export. You can quickly import 2D DXFs or export as well. 3D DXF import and export is also available in the software. You can use SAP integration, especially for ArchiCAD. You can export analytical model to SAP or ETABS by S2K and E2K files. You can also export your model to the Tekla structures. So let's just see these export process and how we can create a model from scratch in our software. So you can we can just double click on our application. Okay, so it's already open. So let's just create a new project. I'm gonna insert a new project name over here, webinar. Okay. So we have different templates for different territories, because each territory has different project delivery habits. So now I will continue with the one of our Eurocode templates, and let's just click OK button. So there are several ways to start in our software. Like you can just import IFC, DXF, but of course in this session I will just show how we can create from scratch. But for instance, you can quickly go to the building setup tab, and you can just add your own DXF file from here, and of course use this DXF as a layout. Okay, and of course if you need, you can just import grids, columns, walls, etc. But in this case, I will start with our orthogonal axis generator. So you just need to pick a point, and it can create all axes with a single click, actually. So let's just insert the axis spacings. By the way, I see some questions. I will take the questions at the end of the session. Okay, we will have Q&A session after the webinar. So okay, so let's just insert axis spacings 5,000, 6,000, 4,000, and 3,000. So let's just click OK button, and all grid system will be generated in the software. So what can we do now? I will show some our access features. For instance, let's just click properties, and we have some different insertion methods. Okay, let's just continue with the third axis insertion method. Okay, you just need to pick 2 points, and you can specify the curvature distance like this. Of course, if you need, you can just click on it and change the axis label just like this. Let's say that we have a different facade on our building. So I will just delete this axis and create another multi-segment axis at this position. Okay. So I will just select our actually grid intersection, and then we can finalize this axis command with the right click. So let's just continue with our column elements. So to create a column, you can click on the column button, and you can pick a point on our grid system. You can just box around, or you can quickly change the column dimensions and align them even on curved axis. We have an extensive column library. For instance, circular or L-shaped columns are available in here. You can select our steel sections as well. So I will continue with the like circular columns. Okay. And at the end, we may have like L-shaped column here. You can quickly rotate it. Okay. So to change the eccentricity, we have several buttons over here. So you can just update it, or you can just select the element, get into properties, and use cursor keys. Okay, we have cursor keys on our keyboard, so you can quickly arrange the proper position for this column. Okay, so let's add our walls, shear walls. So to create the shear wall, we need to pick 2 axis intersection, and then shear wall will be generated. Okay. If you want, you can quickly create wall opening on it if it's necessary. Of course, if you need, you can quickly select these shear walls and merge them with a single click. Or, of course, you can separate them just like so. So the next thing that I want to talk is our beams. So you can just create one by one, or you can draw along the columns. The software will detect the column nodes and automatically split the beams just like this. Of course, if you need, you can just box around, and you don't have to do you don't have to insert these beams just one by one. Generally, I'm using this boxing around feature. Okay, so we have some beams over here as well. Okay. So let's just add a curved beam at this position. So you can quickly connect them and press the F2 button to specify curvature distance. For secondary beams, we don't need to create additional axes. We can just use these intelligent points, and you can snap them and connect to the other side. Or you can just specify a distance by F2 button, like let's say we have 1500 millimeter, and you can directly connect to the other side perpendicularly. Okay, as you see, we haven't created any axis in here. So I would like to talk about our slab additional load library. So before we create our slabs, we need to create our slab additional load library. I will use our default values, but if you want, you can just click on this green plus button, and you can add your own load and its layers just like this. Okay, so let's just use our slab button, but before slab creation, we just need to create our combination. So I will explain this part later. By the way, let me close my email. Okay. So let's just click on OK button, and now we can add our slab elements. I just increase the slab thickness. You can change concrete cover, angle, or level of the slab. So you can play with the loads. For example, in my case, I have just selected room slab as a slab additional load. If you just right click on impose load, you can see the list of regarding to the selected code for live loads actually. So I'm gonna select 2 kilonewton and click to the beam zone just like this. So even in seconds you can create all slabs. And of course, by the way, it's so easy to create cantilevers in here. For instance, I will just insert the length of the cantilever, 1200 millimeter, and you just need to pick 2 points and specify the direction. Of course, if you need, you can just I will just do the same on the other side, just like this. So, like except rectangular geometry, we can create any kind of, let me pick this intersection. So any kind of cantilever edge with these slab edge feature, slab column edge feature. So you just need to draw the slab edge and insert the slab between these edges. Of course, we can use this feature for complicated column geometries. So you can draw any kind of column geometry, and you can transform this element to the column member, just like this. So you can also simply insert your reinforcement inside. Just you can insert all links, all bars, or you can insert intermediate bars manually, just like this. Okay. You can add tie bars. So as you see, any kind of rebar adjustment can be done in here. Okay. So let's just click OK button. We will not use this column. Of course, in a normal life, we don't see such geometries, but of course, if you need, you can use this feature. So let's just talk about our loading part. In our loading editor, actually it's been recently added in our latest version. So you can add any kind of load using this feature. In my case, I'm gonna add wall load. Okay, so we have different wall loads in our library. You can add your own wall load as well. So in this case, I'm gonna select 200 brick wall. Okay, 200 millimeter brick wall. You can add openings. You can specify the wall height, and you just need to select all beams, and the loads will be automatically inserted. Okay, just like this. Of course, if you need point line area loads to add in a plan view, you can also do this by this button. So let's just add 1,000 millimeter brick wall, and we can add the height of the wall as well. So you just need to draw on the plan, and that's all. Okay, so let's just add new stories. So to do this, you can go to the Building Setup tab and insert story. For instance, we will have a 5-story building, and I'm going to click OK button. So if you activate our 3D view, you will see that actually the stories are created. You can see the axis. Now let's just generate the first stories information to the other stories. I've just left story 5 as blank, so because I will add some steel elements, so I don't want to copy the concrete ones to there. Okay, so now I just want to, on the 4th story, we will have flat slabs, so that's why I would like to delete my beam elements with a single click. Okay, just like this. You can also select these loads and delete these loads with this command. Okay, let me also delete it. Of course, we can select these elements multiply. For instance, you can just create a rectangle. You can just box around them and activate the member tables. So in here, you can change thicknesses or loads, whatever you want in here with these parameters. So in my case, I'm gonna increase the slab thicknesses with just single click. Okay. So now let's go to the 5th story. Okay, let's go to the 5th story and add some steel elements. But in my case, I would like to use 3D view for this purpose. Okay. So I'm going to click on 5th story, and we can add some steel elements in here, okay, in the modeling tab. So let's just click on column button, and as you see in here, we have several sections. We have really extensive library. If you want, you can use, for example, built-up steel. All these sections are parametric. So, okay. I'm going to continue with the HEA. You can rotate the section just like this with the section angle button. And I'm going to click on axis intersection. Okay. So now I would like to continue with the steel beams. Okay. So let's just click on modeling tab, and we have steel beam button over here. Okay. Again, you can select any kind of any section in here. So I will continue with the IPE. Okay. If you need, you can add, of course, curved beam for steel elements as well. But in my case, I will add some end releases, so it will be hinged beam on the simple direction. Okay. So the next thing that I want to talk is our truss elements. So to create a truss, you just need to pick 2 column points. Okay. So we have several truss types and patterns, but of course, if you want, you can import any kind of truss by import from DXF. For instance, I did before for our Baltic region, and you can see that even such a complicated or different trusses can be inserted by import from DXF button. But in our case, I will continue with the with truss type from our library. So in here, top chord can be selected from this part, and of course you can play with these settings. For now, I will just skip them, and let's just create our truss element just like this. But on the other side, let me offset an axis minus 1000. Okay. But on the other side, I would like to create some beams, like to have an apex. So to do this, you can quickly select again any section, but this time I will just cancel these hinges. On 3D, we can just specify a value to change the elevation of the end actually node, and I will do the just opposite for the other side. Okay, and that's all. So even in 3D view, you can quickly model your elements just like this. So then I'm going to continue with my actually purlin girth members. So to create a purlin, you can simply select purlins just like this. So in here, we can select, for example, generation method can be selected by spacing. or okay, or you can just change the first member's offset, or you can do some adjustments from here. Okay, so let's just delete first member, then change the other members, or maybe, yeah, here. Okay, and change the other members offset value from here. Then we can use the same properties for the other side. Okay. By the way, I think there are some questions. Okay, so let's just continue. So again, I will continue with my girds. They're exactly the same like purlins, so I will not. By the way, I haven't shown that we can remove segrows if you want, or you can manually do some adjustments. I will do the same on the other side. Okay. So let's just add our girds. To add a gird, we just need to pick 2 columns. Again, you can select any section, or you can just delete some elements. For example, I'm going to delete the bottom member because it will collide with the base plate, so that's why I just selected this option. Or if you want, you can remove segros from here. Okay, I will do the same on the other side. Okay, so let's continue with the braces. So to create a brace, we just need to pick 2 columns. Okay, we have some, of course, any section can be selected, but if you can just double click on it and change the section from here, just increase a bit the thickness. Of course, we have different brace types like V brace, K brace. You can just invert them as you wish. So not only diagonals or X braces are supported in the software, but also we have added V brace, K brace, and their inverted positions. So let's just continue, and I would like to just give small offsets because it will be easier when I create connections. Otherwise, the end plate can be a bit longer, or it can collide with the actually this connection. There will be a column beam connection, so that's why I prefer to decrease the elevation of this brace just like this. Okay. I think, let me do this again. Okay. Yeah, both of them are decreased. So on the other hand, what we can do, just let me show you. We will create the same on the other side. Okay, just like this. And lastly, I would like to show our claddings. You just need to add, just click on the purlins, and claddings will be added just like this. To insert a load to the cladding, you just need to pick cladding and select the Edit Loads button. full uniform loads can be inserted. So I will just insert magnitude and box around all these cladding segments. So if you hover over on it, you can see the inserted load like this. Okay, in our last version, we have added also steel dome. In this model, we don't have a steel dome, but I will just create as a sample. You can just play with these parameters, and once you click OK button, the steel dome will be generated. But as I said, we will not have a steel dome in this model, so that's why I have removed it. Of course, frame members were improved a lot. So, for example, you can just create a curved elements just like this. Okay. Of course, apex distance can be changed, like maybe 2000 millimeter will be more suitable. And of course, you can change the plane angle as well. So any kind of curved frame element can be generated just like this. Okay. So I think we have just we have just finished our model. So let's just talk about our analysis features. Okay. So I'm going to click on building analysis button, and then let's continue with our materials. So any kind of material can be inserted from our library, or you can create your custom material just like this. Okay. So by the way, if you need, you can use this material for all elements, or any kind of material can be used for each story. Okay. For example, for the first story, I would like to use C30, but the rest will use the C25. Okay. We have different seal grades in our library. You can select any of them, or you can create your own seal grade from here. By the way, you can just filter unwanted diameters from here, and any kind of rebar symbol can be used. So you can just play with these parameters as you wish. In the settings center, I would like to mention a couple of stuff. We have a lot of languages we are supporting, like English, Spanish, Romanian, so you can select any of them from here. We have also different report languages, as you see. So let's continue with combinations. So in the loading generator, you can create a roof live load, snow load case, rain load case. So all these load cases can be generated automatically, or for example, wind loading, okay, soil pressure from here. So all this kind of different load cases can be generated automatically. Of course, if you need, you can just add your own load case from here, and you can add different combinations with this add button. But I will use the default values. So in the model options, we can select shear wall model, and in this model, actually, I will use finite elements shell model. Generally, I suggest you to use this shell model because we were previously using this mid-pair model, and at that time the computers weren't so developed as in the present time. So that's why I generally use finite elements shell model to obtain more precise results. So slab model, in this case, we will just mesh our slabs with this button. Okay. Of course, if you want, you can just cancel the diaphragms from here and use the own rigidity of these slabs. It's up to you. So let's just run this analysis. Okay, I'm gonna just mark these options. Okay. So during the analysis, if you have some questions, I can take. Yeah, actually, Mr. Arnold, we will add these presentations recording to the our YouTube channel, so you can find there, I think, a couple of days later. So yeah, I showed infill wall. You can just draw on the slab, or you can add this via our load editor. How we can get this webinar step by person practice. Okay, I think it's been answered. We are not following what you are saying because we are not seeing. Okay. Mr. Akabo, I think, had some problems. Okay, by the way, sorry for the inconvenience. I think I was just thinking that you are seeing the screen, but you are actually, you were watching my camera view. I'm sorry for this. So, okay, the analysis is about to be completed. Of course, we had several enhancements for this analysis duration. As you see, like, I have just meshed 4 stories, and it's about to be completed. So I think there's just one more. Yeah, we will share this webinar in our YouTube channel. Yeah, we can talk about temperature load, but let's just continue like this. At the end, we will have Q&A session. So I will show that, okay? How we can insert temperature loading, okay? So let's just review quickly building analysis. Okay, in here, you can quickly select results or displacement. Let's just review diagrams. For example, I'm gonna select the axial load, and so we can quickly review axial loads under the selected load combinations. Okay, so if you select contours, you will see the effects actually tab, and in this effects tab you can just select the required steel areas. For example, let's just click on direction 1, okay, bottom steel, or quickly let's just review others. For example, direction 1, top steel. So by the way, we can also change these contour values, okay, to be able to review better. So in the actually under contour tab, you can click on edit user definitions and change the rebar area from here. You can just transform this value to the known actually rebar reinforcement area. Okay, so let's just click on update button, and this actually contour value will be changed with the rebar area. Okay, So you can quickly understand that these red zones are crossing this value, and we need to add extra additional reinforcement for these zones. Okay, so let me close building analysis model. Again, I will just create my foundation. Okay, let me delete these elements, so I will create from scratch. In the modeling tab, you can create slab edges such as rectangle geometry, and we can insert, for example, 600 millimeter thickness, and concrete cover can be 50 millimeter. Okay, so then we can add some actually pad footing, so we can insert pad footings in batch mode, and of course you can redesign all of them with a single click. Let me show here. Okay, once you click OK button, all these pad footings will be generated just like this. So on the corner, we can add, for example, pile cap. You just need to select insert pile cap comment and click to the design button. So the pile cap will be placed just like this. Of course, you may need a strip footing. To create a strip footing, first we need to insert some beams. Let's say that we have 70 some beams which has 70 centimeter height. Okay, and we can select these beams to insert a strip footing. I generally suggest you to use the envelope loading. Okay, if you want, you can change the cantilever values. For instance, 500 will be okay. Footing depth will be 600, or maybe 500 will be sufficient. Okay, let's just click OK button. So as you see, we have completed all foundation elements in a single model. So now I would like to add actually slab strips. So to create a slab strip, we need to select the direction, then type, finite element strip type can be selected. If the finite element strip is selected, you don't need to use boundary conditions. I mean, it's valid for fixed band strip actually. So I will just draw a fixed band strip, and we just need to specify the borders. Okay. On the Y direction, I will do the same. Okay. So after this, now we can perform our foundation analysis. In here, you can play with the shell element size, but I will use the default values. Okay. So in here, you can review the foundation model under these effects. You can review soil pressure, whether it's satisfying or not, or you can check the internal forces, required steel areas. So now we just need to run the slab design, and once you run slab strip design in batch mode, all reinforcement will be generated. Just like this. Of course, you can design strip footings from here. We have foundation beams. You just need to run beam design and reselect all bars with this button. By the way, you can play with these actually reinforcement. You can just change the numbers or diameters from here, for example, just like this. Okay. Let's continue. By the way, I just skipped, but in the story operations, you can change, for example, levels, story labels, descriptions. Okay, foundation depth can be set. So please set this value with your foundation thickness. For example, if you have a 60 centimeter rough foundation thickness, please insert 60 centimeter here. Okay. First bottom elevation is the top elevation value of your foundation. Okay. So it's changing the levels. And regarding these levels, we are generating the details. Okay. I would like to continue with the column design. Okay. So let's just reselect all bars. Generally, what I do in here, first I just select filter and I'm checking whether is there any failed members or not. As you see, we don't have any insufficient member. So let me just click on one column to show the interface. If you want, you can add some intermediate reinforcements just like this. Links can be selected from the link patterns. These patterns are also located in our settings. So once you click on column analysis, you can see the interaction diagram, and all of our combinations are remaining under the interaction diagram as you see in here. Of course, you can see the diagrams. You can check the for instance, the displacements for the both direction. Okay. If you want to see the preview of drawing, you can click this button and see the elevation drawing of your member. Okay. Of course, if you need, you can copy these bars and paste to the others. So let's talk a bit story beams design. So what we can do in here, you can just again reselect all bars. Again, I will do the same. First thing that I do in the interface, I'm checking is there any insufficient member or not. So I suggest the same for you. Okay, for example, is there any failed members? No, there is none. So if you want to check the interface, you can quickly play with the numbers or diameters from here. Okay, so you can customize this actually rebar patterns or rebar adjustments as you wish. By the way, we provide bar list as a report, so you can quickly see which beam has which actually rebar adjustments. So you can add your generally, we don't add to our project submissions, but if you want, you can use it, of course. You can group beams. If you group a beam, you will have a single calculation report for the grouped members and for also single details for them. So it might be advantages. I mean, it has some advantages in my opinion, of course, if you use it. So let me show again 3D view, and we are going to push this model to the Prota details environment. Okay. So in Prota details, we can create all drawings with a single click. Okay. So what I'm gonna do in here, I will select Detail Drawing Manager, and of course we can change the plan settings or elevation settings in here. For example, I want side dimensions. Maybe we can change the hatch patterns. For example, I generally prefer the solid ones. In Poland, we don't use column application plan frequently, but I don't know in the states of Africa, but we don't use column application plans. So you can insert these plans and actually elevation plans into the sheet. Okay. So let's just click to the draw button and pick a single point in an empty space. So now the software is preparing all details. Okay. Of course, it may take a bit time because like at least 20 different plans are being generated during this time. So now it's been generating the BIM elevation drawings. Okay, I think it's been created. So as you see in here, like all these, the reinforcements that are created are intelligent. You can just play with the lengths or change the diameter as you wish. Of course, if it affects the calculation, I suggest you to do this in ProtaStructure environment. But for instance, we can just increase the diameters. Okay. Or you can draw any kind of like polyline element and transform this element to the actually to the intelligent reinforcement element. Okay, so let's just convert this to the rebar, and with a single click you can create the quantity table of it. Okay, it's also easy to add this quantity report to the actually we can export it to the PDF, Word and Excel files just like this. So as you see, the software has precisely created this opening reinforcement. Okay, just like this. Let's just review our BIM details. All these reinforcements are, again, I would like to underline, all these reinforcements are intelligent. You can play with their properties. Okay. So as you see, the reinforcements, even cranked parts, are being generated precisely, just like this. Here you can see the our strip footing, head footing, and pile cap. So We have also some macros in our library. For example, let's continue with our retaining wall. And you can add shear keys, you can change the positions, okay? Or you can add shelves. Any soil parameter can be inserted from here. Design settings, by the way, you can select any code like American Euro code or Turkish code in here. Once you click prepare drawing, it will be design and detail with a single click, just like this. So if you want to return to the properties, you can just right click and select the edit retaining wall. So I mean, once you create the details, you don't lose these actually retaining wall properties. So just briefly, let's just check steel scaffold part. I will just create a sample detailing, so because we don't have too much time. Okay, so you can see the scaffold detailing just like this. Also, we may have, if you have a pool that you want to design, you can select the geometry from the gallery. Let's say that we have like L-shaped pool. You can just change the design parameters and length from here. In the properties, you can select the soil model, okay? Because we are using these soil models for the later loads. Then you can draw first design, of course, then draw the details, okay? Okay, I think Prota Details is clear as well. By the way, Prota Details has all CAD features, like you can use like line, polyline, hatch, trim, extend, so all these commands are available in the Prota Details. So finally, I will just push this model to the ProtaSteel environment. So in ProtaSteel, we have a revolutionary feature that is called IntelliConnect. So I will start first with this feature. But before, I would like to hide these concrete elements. For instance, let's just hide these elements just like this. Actually, yeah, it will be better if I do like this. Okay, so what I'm gonna do in here, first, I will just select all elements and right click. In here, we have IntelliConnect feature. Then we can create all purlin connections at once. Of course, if you want, you can select a specific connection, or we can also reverse them. But in my case, I'm going to select the auto option for the most appropriate connection. So the software has generated the purlin connection with a single click. Then I'm going to continue with the GERT connection. Okay. If you want, you can reverse them just like this. Or again, I'm going to select the automatic option, and let's just run the GERT connections. So normally doing one by one this kind of actually connection insertion can be really time consuming and tedious. So IntelliConnect, in this case, IntelliConnect is really actually it's an amazing feature that can actually save your time, and in really a very short time you can complete your connection design, of course, connections and connection design. So let's continue with the truss connections. Okay, so all these truss connections has been completed just like this. For this part, we are generally using macro, so I will show later, because IntelliConnect wasn't able to insert a connection for this part. I will show later. So again, we can continue with the, for instance, column beam connections. Again, if you want, you can select any specific connection, or you can just leave it to IntelliConnect for the most appropriate connection. So normally creating such a connection manually can take a huge time, but with the IntelliConnect, I just use a couple clicks, that's all. So again, I would like to talk a bit our macros. So let's just start with base plates, for instance. You can just click base plate and select the column element, just like this. Of course, you can customize these base plates as you wish. For instance, you can just press the enter button, select the macro, and we can just do some adjustments in a batch mode. Okay, we can just remove some stiffeners. Okay, normally before these stiffeners were colliding with this brace, but I turned off these actually stiffeners in a batch mode. So let's continue. For instance, IntelliConnect couldn't generate a connection for this node, but we have really handy connection for this part. So I'm gonna use Apex Truss gusset connection. Okay. So first I will actually select the primary members, then secondary members, and that's all. Okay, so let's continue with the actually column beam connections. We just need to insert some stiffen end plates. So first select the main member, secondary member, and right click. Then, for instance, if you want to insert a connection for this brace, what we can do, we can again use the like one of our brace connections. Actually, it's in here. Corner bolted gusset plate will be more suitable for this part. Okay. Of course, you can also insert welded gusset plate. So here you can clearly see that such a complicated connection can be done by automatically in ProtaSteel. Of course, in some cases, the software may not manipulate the member length. So for such cases, you can just double click on it and play with the member properties, just like this. If you want to match the property with this member, you can use match elements command to apply the same chains on the other side. Okay, let's continue because we have here the same kind of connection on the other side. Let's just add step-in end plate, and of course, if you need, you can add your brace connection as well. I will do this brace connections in here just like this. Okay. By the way, you can manipulate this connection by selecting the macro icon, or you can press the M and Enter button to be able to get in the properties. Okay. So bold properties, wells, like figures, all can be customized by user. Okay, so let's continue. I think I have completed. Let me check. Okay, so let's just add these brace connections as well. And here on the other side. Yeah. Of course, if you have brace connections, you can also use, for example, bolted gusset plate, just like this. On the other side, I'm going to use the same connection, bolted gusset plate. If you want, you can just play with this geometry by macro properties from here. So I think we completed almost all connections. Yeah, actually all connections. So now I would like to show some handy features. For example, if you want, you can just select grid and create a view from grid automatically. Okay, so you can clearly see that. Maybe, yeah. Because we hide it actually elements, so concrete elements. So let me show all, and now you can see these actually views, which actually were created automatically. But of course, if you need, you can just press F4 button for the top view, and you can create your own view, just like this. Or, for instance, you can create a view for the other side. Just like this. So now I would like to create a connection detail. So to do this, I would like to select this connection, okay? So what I'm gonna do first, I will select these connections over here. Okay. Then we can use, actually under Still tab, we can use Detailing Item Manager. Okay, Detailing Item Manager. So in this case, the name will be Detail A. Now I would like to add the main objects, for example, this column and these beams. Just right click. The actually connection detailing item manager, the item cube actually has been generated. If you want, you can add 3D view from here. I will do the same for this, actually for this part, but let's just hide these elements. Okay. Of course, if you need, you can add just some anchors as well, just like this. So what I'm going to do, I will just select these elements, and again I'm going to create another detail. So detail D, just like this. Again, we can select the members that we want to see in the detail. We can add 3D view as well. I generally prefer to add 3D view from here. You can just change the view directions from here. Okay. You can select, for example, instead of top, you can select bottom or other directions. Okay, so let's just close it and pass to the actually drawing side. So to do this, I'm using a Control D button shortcuts, and with F6 button you can create any kind of drawing just like this. So general arrangement drawing. Okay, so let's just open this drawing by double clicking. And in here, for example, I'm going to generate the 3D view of this building. Of course, each actually view has own viewport property settings. So for example, I would like to use hidden line. We can just change some labels. For example, I would like to see the view name under of this detail. So we can filter some of the elements. For instance, I don't want to see grids or maybe, or you can just select that you want to see in this view. For instance, plate, bold, weld, and profile elements. Okay, just like this. So now we have a better view, actually more clear than before. So the next one can be our viewports, just like this. Okay. So if you don't want to see, for instance, the concrete part, you can just hide them by using filtering options. For instance, in the general tab, I don't want to see concrete members, and that's all. So we can also just limit the views from here. So both of these views can be used to produce details. So once you click connection details, these details will be generated automatically. So I just need to place them to the proper positions, just like this. Okay. So normally these are really time-consuming details, but you can quickly, with a single click, you can quickly create all these details. So, for example, I just want to add a diameter, and once you label actually diameter label. So once you click on these bolts and select the bolt annotation, you can quickly add the diameter's value, just like this, or for example, profile. So all these settings can be created as a label in the view. You can add some actually dimensions. For instance, I'm going to add, I'll just pick these points, or we can add vertical dimensions as well. Okay, so any kind of dimension can be added just like this. Of course, we can export these, actually all these details to the DXF file. Let's save it. Part drawings are fully automated, but before part drawings, actually before detailing, I suggest you to do numbering. Okay, we need to number the elements. Okay, so we just need, actually assembly drawings are fully automated. You just need to select the member and create the assembly drawing. Okay, let's just check our assembly drawing. So this column with all these plates, like all these actually parts, plate elements, all of them were generated in a single drawing. You can also see the material list. Let me turn off this name. You can also see the material list, plates, and all of them were dimensioned. Okay, we just precisely create these drawings with welding signs and actually with their dimensions, just like this. Okay, so I would like to show part drawings. Part drawings, normally once you select the member and select assembly, you can see that all these elements will be provided in the assembly drawing, but part drawing is only the member, the column member, just like this. So generally we don't need part drawing so much, but if you want, of course, you can. Let me do this once more. Okay, if you want, you can quickly generate this part drawing with a single click. Okay. So, of course, if you want, you can, for instance, you can quickly create your connection reports. To do this, you can just select the macro and create your connection report with a single click. Okay. So all code requirements, formulas are provided in this report. Of course, you don't have to select one by one. You can select whole model and create these reports at once. So you don't have to do one by one. On the other hand, you can review the, you can colorize this sufficient colors with green, for example, just like this. As you see, this just hunch connection is like failing. Maybe we can increase some thicknesses or weld thicknesses, and it can satisfy the connection. Okay. So I think except these hunch connections, all of them are satisfying the selected code. So let's just turn off this view, and if you want, you can activate the summary table and see the failed elements in here. Only, as you see, only the hunch elements are failing in our case. Of course, what we can do, we can select all elements and create material takeoff with a single click. So, for example, profile list. Again, this one is plate list. Even we can create, for example, bolt list or washer list. So we can quickly see even a washer list in here. Of course, on the BIM side, you can export this model to the IFC. So let's just create an IFC file. And for CNC machines, you can export this model to the as NC file, or you can export to the Tekla. But for Tekla, you need to download Tekla IO software from the website. It's kind of add-on. So once you get into our website, you will get into the downloads, and in here you will see the actually Tekla IO software, which can integrate with the Tekla structures. So let's just check the quality of our IFC file, and you will be, in my opinion, you will be surprised in this case. Let me open the Navisworks. So think that I have mechanical, electrical, or plumbing elements that I received from another project stakeholder, and we can run the clash detection and check the clashing part with our structural elements. So we are providing even bolts, plate elements. So you will see. Let me find that. I think it will be on desktop, but let me check. Webinar, yeah, here. IFC. Okay, let me just generate it once more. Okay, it's in here, so again. Okay. So after this, I will just show Revit, how we can import Revit and export back to the ProtaStructure environment. Okay, so as you see here, even plates, bolts, all elements with their properties, even welds are exported to the IFC file. Okay, so let's just talk a bit our Revit export, import and export actually. I will take the questions at the end, so just 5 minutes left, then I will take the questions and show if there is any complicated one. Okay, so in here, if you decide to import a ProtaStructure model to the Revit, first you need to create a new, select a new project, and you need to use our own template. So in our own template is located under Prota library folder and under templates folder in here. Okay, let's just click OK. Now default actually level values will be generated, so I'm gonna delete them. I don't need actually, because ProtaStructure's elevations will be automatically created by ProtaBIM, so that's why I don't need any default levels. I'm gonna select import from ProtaStructure. Then we can select our project. So in our case, it will be on my desktop. I just need to show the file. Okay, here. So then you can just select the actual file which has extension .prota. Okay. So now the actually import process has begun. You can clearly see the actually preview of it. It has 6 stories, like we use Eurocode. You can see the project name and last save date. So let's just click on next. It will be first time, the import will be first time. So I just selected this option. These red ones are that are elements which are not mapped, but please make sure that all elements are mapped. Otherwise, these unmapped elements won't be imported to the Revit environment. Especially, for example, let me show, especially these kind of trusses, like side-to-side trusses. This kind of actually side-to-side trusses won't be exported because we don't have the family in the default. You have to create it. If you can create this family and match by yourself, it will be also imported to the actually Revit environment. So by the way, I will use another model, so I should open this in there. So let's just select start button. The important point is we are not just importing blocks. We are not using IFC. We are actually creating Revit's own elements, own objects. So that's why, let me show you in 3D. We can change the render mode and detail. Okay, so for example, this one was only single L shape, so I was able to import to the Revit environment, but side-to-side ones may not be imported, so you have to generate its family. But even slab drops were imported. You can clearly see here. The thickness is 20 centimeter and the other side is 25. You can see in here. So what I'm going to do, as you see, all these elements are family. You can just change base offsets or top offsets. Let me show you. just like this, you know. So you can do any adjustment if you need. I will delete some elements, and maybe I did some adjustments in Revit, and I want to export to the ProtaStructure and continue to my analysis. So to do this, we can use export command and select the file that we want to use, Revit integration. Okay. Again, if there are any unmapped members, you need to remap them. So in the BIM tab, we have Revit import button. So again, I just select Revit import button, and we can update our existing model. Of course, if I can switch to 3D view, it will be more suitable. Okay, so as you see, the deleted part of the building, actually this adjustment has been applied to the ProtaStructure as well. Integration status, you can clearly see the elements which are not changed in our model. So you can quickly see the revision that are made by other BIM engineer or structural engineer, just like this. Okay, so my presentation, actually I completed my presentation. So if we will pass to the Q&A session. Okay, so I will take questions. Okay, so how to export Tekla? Unfortunately, I don't have Tekla, but you have to download this Tekla.io add-on, and then you need to use our exported file. By the way, Mr. We will share this video on our YouTube channel. You can just you know, get into our YouTube channel from here, because somebody asked. I think it's clear, but actually, so we have a YouTube channel, and as you see, we have plenty of different videos. So please review them, and if you have any question, you can share with global support at protasoftware.com. If isolated pet foundation labs, how do you deal with the error? Okay, if the isolated foundation, let me open the other model. Maybe this one will be better. Okay, so if let's say that these pet footings are overlapping with each other, so what you can do, you can actually let me go to plan view. It will be better. So you can select them, and you can insert combine pet footing. Okay, but these actually for these columns it may not be suitable, because they have actually too much spacing between them. So So it will be something like this. But of course, if these columns could be more closed, these actually combined pad footing would be much more smaller. Okay, exporting drawings from Prota details to the DWG. The drawings come in different scales. How can I read the same scale? Actually, in here, let me open the Prota details. So actually, you can modify the scales in Prota details. Let me show you. Let's just create a single form plan. Wait, it will be better. Okay. So let's say that we have such a plan, and so in here in the settings tab, let's get into the options, scales. So in here we have drawing and other scales. So in my opinion, you just want to you can just play with these. For example, the setting and other coefficients will be automatically actually arranged with these coefficients, or you can just specify one value just like this. For instance, let me just make it 100. Okay, so it will be automatically set it just like this. But I suggest you to do this in AutoCAD, because in AutoCAD there's an enview command, enview. You need to use layouts in AutoCAD. You can use enview command in layouts, and like there should be you can just insert the scale with the zoom command. Okay, please just check this in the internet, like layout uses in AutoCAD. You will find it's I generally use this method. Column design software doesn't consider the slab as brace. So the coefficients for the effective length factors unrealistic. But Mr. Ted, you can change the members' effective lengths manually. Of course, at some points the software may not detect these effective length values automatically. So if you realize something like this, you can just go to the especially for steel elements, for instance. I will show ripped slabs in a second. Just after this, for instance, you can just go to the design tab for our steel elements. Let's say, for instance, trusses. So once you get in the truss, we didn't design this, but let's check all. So in here, for instance, if you double click on it, you can get into the, for instance, top corp design. And in here, you can manually edit the brace length or backlink length from here. So in such situations, you need to adjust these values manually. Okay, ripped slabs. Okay, so for ripped slabs, maybe I can use. We can quickly create another model. Okay, let's just use Polish Eurocode. Again, with the orthogonal axis generator, I will use the default values. Just we can quickly add some columns and beams. Okay. And now we can add our ripped slabs, just like this. So if you want to change the rip direction, by the way, rip direction, you can use insertion part, for example, 90°. You can change the, for example, rip insertion reference points from here, just like this, or you can just specify a point with this cursor button. Okay. For example, I want first rip to start from this point. Okay. Just like this. Okay. So as you see, you can set these rips with this actually reference point button. So if you would like to use a continuous, of course you need to do the same chains like this. So of course they should be continuous. So like this. By the way, I didn't insert any load, but you can quickly select all, get into the rib slab table and let me select again rib slab table. Or we can quickly use rib slab table from here. So in here you can select the, you can specify the dead loads from here, just like this. So what I can do now, we can add actually slab strips, analytical or finite element strip, both of them are available. So let's just let me first run the analysis. Because I will take the results from building analysis, so that's why I need to run the analysis. You can see that all these RIP elements has been included in the analytical model as a frame member. So now we can add slab strips. Okay, so after this, we can just go to the design tab, and you'll see the rip beams over here. So after you draw these, these slab strips, they will be automatically transferred to this interface. You just need to reselect all bars. That's all. You can produce report from here. Okay, and if you double click on it, you can see the reinforcement in it. Okay. I would like to show in 3D model as well, just like this. By the way, in some cases, we may need to transform them to the actually real beam elements. So you can use this. You can just select the slab and convert them to the real beam elements, just like this. Okay, yeah, temperature load quickly. For temperature load, first we need to create the temperature load case. Okay, so what I'm going to do, I'm going to go to the loading generator, and in here we have temperature loading option. Then temperature loading has been added to the combinations as well. Okay. So then we can add this load to the actually in the load editor. Story one's first story is load editor. So first we need to select a thermal load case. Then thermal load button will be active. Okay. If you want to insert this load in a batch mode, you can use this second option. For example, the axial will allow you to shrink member axially. So that's why you can just specify the temperature difference in here, 30° in this case. These are like if there are temperature difference between surfaces, we can use these two options. Okay, especially for example, you have a structure in a maybe in really cold country, and you are just for example building like industrial, like you are maybe melting some metals, this kind of factory, and if there's a huge difference between surfaces, we can, because there will be a bending moment, so we can use these parameters, these options. So we can apply current story or all model. It's all possible. Once you click OK button, it will be applied. That's all. Then you just need to run the analysis. But of course, I suggest you to turn off the diaphragms. Otherwise, the diaphragm will limit these actually displacement of the temperature loading. Okay, so thank you for your attendance. We have completed our webinar altogether. So thank you for joining us. Hope to see you in our next event, next organization. So if you have any question, please write to the write an email to the global support at protasoftware.com. So see you in our next event.